All right, we've done ionic bonding with monovalent cations and multivalent cations, but all of them have had just monoatomic ions for their anions. They've just been chloride or oxide or sulfide. But there are more ions in the world than just ones made of only one atom. Okay? And that's what a polyatomic ion is. Poly means many, and ion means a charged particle. A polyatomic ion is a charged group of atoms. And there's an extensive list, of course, on the back of your periodic table that you can look at. When you use a polyatomic ion, basically they stay together. Okay, for instance, if you have CO3 carbonate has a -2 charge. Now, I always describe polyatomic ions as groups of junior high girls. Groups of junior high girls, when they go to the bathroom, they all go together. And when one girl dates a boy, it's kind of like all of her friends are dating the boy. And when she breaks up with him, none of her friends will talk to him. So they are groups that stick together. Now, carbonate is one of our polyatomic ions. It has a -2 charge. It acts just like oxide with a -2. Nitrate has a -1 charge. It acts just like chloride with a -1 charge. Okay, so we'll see how that works here in just a moment. So on to the definitions. When you are given the name of the compound, find the metal on the periodic table. That's the cation. Look at the metal's most common charge. It's written at the top of the group, or it's in Roman numerals in the name. Write the charge on the metal in the compound. Okay? So, for instance, down here we've got potassium nitrate. Potassium is a +1 charge. Copper 2 sulfate. Copper has a +2 charge. Iron 3 phosphate. Iron has a +3 charge. Okay? Now, the second name, the last name, if you will, if it is not an element, in other words, it does not end in "ide," with one exception, it's going to be a polyatomic ion. So, our first example, potassium nitrate. We know potassium is a K. He has a +1 charge. Nitrate, if you look at your periodic table, has a -3 charge, or a -1 charge. So, if we follow the law of zero charge, +1 minus 1 equals 0, we write this guy KNO3. Sulfate, if we look at the back of the periodic table, we find that his call numbers here are SO4. He's going to bond with the copper. Copper's a 2 plus, 2 minus 2. Gosh, these are easy. Iron is a +3. Phosphate, PO4, is a -3. So again, that's a 1-to-1. But what if they aren't? What if they're not 1-to-1? I'm going to give you some more examples. So hold on. Okay, I've changed up. Oh, that's interesting. I don't know how I did that. Apparently it works when I touch my finger to the board. I've changed up the compounds we had. Before we had potassium nitrate. Now I'm given calcium. Calcium, of course, has a +2 charge. And we just said nitrate had a -1 charge. Those don't add up to 0. Now, if we were doing calcium with a 2 plus charge. With chloride, we know we'd need 2 chlorides in order for 2 minus 2 to be equal to 0. So we just do the same thing, only we're going to use nitrate. Nitrate has a -1 charge, so we need 2 of them. So we put parentheses around him. Now we have a +2 charge plus 2 times a -1, and it adds up to 0. So we write this guy Ca parentheses NO3 parentheses 2. Second one, copper, again, is a 2 plus. Phosphate, we learned earlier, is a PO4, not PO3. That would be phosphite. It has a -3 charge. Now, if phosphite was nitrite instead, nitrogen with a -3 charge, well, again, we have our algebra problem. What can we what's our least common multiple here? Our least common multiple is 6. So if we have 3 of these guys and 2 of these guys, that would be, I'm going to change color so you can see it easier, 3 coppers and 2 nitrides, right? Well, it's the same thing with our phosphate. We're going to put him in parentheses though, and we're going to rewrite. We're going to need 3 of these guys and 2 of these guys. So we'll rewrite them copper. Now that doesn't mean it's copper plus 3. And you don't say copper 3. It's still copper 2 phosphate. Okay? Our third one, iron 3 again. Sulfate, we said, was a -2. Once again, just like we did, we need to make our algebra problem. What can we multiply 3 by and 2 by? So that means we would need 2 plus 3's and 3 minus 2's. So we end up writing him Fe2 parentheses SO4 parentheses 3. Okay. Now, what if you're given the formula? First, you name the cation. Okay. Then you name the polyatomic ion. Just look them up on the back of the periodic table. And we are going to have a candy bar quiz to memorize them. All right, so our cation here is magnesium. Our anion, our polyatomic anion, ClO4, is perchlorate. Next one, we have aluminum. And we look up the chromium polyatomic ion. Since there's 2, that tells us it's dichromate. Our third one, we have sodium and a hydroxide. Now, none of these included multivalent, so let's throw a couple of those in there. What if instead of magnesium, we have iron perchlorate? Okay, his name is going to be iron perchlorate, but we have to do our detective work. Look up on your periodic table. You're going to see that perchlorate has a -1 charge. There are 2 of them, So what does iron's charge have to be? It has to be a +2. So this is iron 2 perchlorate. If we change aluminum and switch him out for cobalt, once again, we have to do our detective work. We know dichromate is a -2, and we have 3 of them. What does cobalt have to be here? Okay, you thought it was going to be 2, like aluminum was, but it needs to add up to a +6. So this is cobalt 6 dichromate. If I had written it, the 2 there, then we would have cobalt 3 dichromate. Okay? All right.